What we'd like to do today is to demonstrate the installation of our new Marprene tubing that's replacing all the tubing, in most cases, on all of our analyzers. You may have a little bit of confusion about why, if you put the new tubing in, this roller will bind up. Simply, this is a Celastic piece of tubing in there right now. And I'm just going to show you that there's rollers in here that actually two are always in contact with the tubing as this turns. And this capstan has to be pressed up enough to make a seal against the rollers so that it can pull the water or the sample or liquid up through the tubing over into your cell. And this little clip fixed the tension on that roller. So I just want to demonstrate. That if this is pressed up too hard, when you turn your pump on, it's not going to turn. You see, oh, there's something wrong with the pump. That's not the case at all. You can see that that'll pump. There's liquid coming up. I put the straw in the water. If you look in here, you'll see the liquid coming up. Take a little bit to get it. It's a long tube coming out the bottom of the analyzer. And there it is, I think. Solid slug coming through, going over, and coming into your cup. I'll stop the noise so you can hear what's going on. So in order to change the tubing, you just take this clip, and in order to be able to push the clip out of the way, you push down a little bit, and the clip will roll off to the side. And then you take your tubing. Remember, when you pull this off, any liquid that's in it, since I just filled it, notice nothing's moving yet until I release it from the rollers. So the tubing just goes on to barb fittings. You can see how soft the Celastic is and thin-walled. The tubing that we're replacing it with is called Marprene, and you can see that it's a little bit thicker. And it's a little bit harder to bend. So when you get this tubing, you just push this on to the top, stretch it over to the other side, and push it in. Now, the lengths of these tubings, it comes with the longest tubing, which is still more than you'd ever use. And because this is like a balloon when you're moving liquid in it, if you have a lot of tubing and a lot of surface area on the inside, you could get degassing between analysis. So when you start up, you're putting, instead of solid liquid with air in between. So I like it to be as short as I can without, making it so tight. And also it gives you a little bit of area if you have to cut something off. So we use a cutter, cut the tubing, and then you just roll it onto the barb. Same thing on this end. You just make sure that it's not pinched. With this thinner tubing, it will get pinched like that. We normally will put a twist in it so that it goes a little bit sideways. Okay, so you can see that that's full. Now, if I lift the capstan up and I put the clip under it, in our diagnostic menu, I don't know, maybe you want to get up here for a second. In the diagnostic menu, yes. Print the menu, no. Review results, no. Review alarms, no. Hardware test, yes. Reset all. That would be resetting the 4 to 20s that are holding the last readings, and we don't want to do that. Fluidic control, yes. So now the top line asks you, do you want the stirrer? I say next. Do I want the titrant, which would be this pump over here, the piston pump? I say next. Reagent 1 is here. and this happens to be the cow pump. This is an old demo unit that we have outside of our lab that we use to test different things in. So what you want to do once you've selected the pump is to hit the edit, and you tell it you want it to be on. Now this is what's happening in the field, and customers are saying the pump can't turn that tubing. It's only because it's thicker. What you do is you just push down on this metal like this and let it go, and push it down again, and there you go. So what I do is I'll stop it and let it run. Because the rollers do flatten, it does take a little bit of a set. It's not a bad idea if you're doing checking the flow rates of your pump to let this run for a little bit so it can take a set, and come back, and then you can set up your flow rates. And that's it. It's a simple process, but if you can't get the pump to turn, you could get confused and say there's something wrong. That's quite normal if there's too much pressure for the pump to jam. That's how it's made. It's sending pulses to each one of these. Each one of the coils, there's 4 coils in there, and it's just doing that whether this is turning or not. So there's no harm. It's not an electric motor that if you bind it, it's going to overheat. It's just sending pulses to each one of the coils. And that's the end of my demonstration.